All right, let's jump right into this. Welcome to today's Explainer, where we're embarking on an epic journey, the evolution of a protocol that quietly, almost invisibly, rewired the entire fabric of our digital world. We're digging deep into the comprehensive 2026 technical blueprint that details the architectural evolution of Bluetooth technology. And look, this isn't just your standard story about pairing a phone to a smart speaker. It's really a masterclass in how rigorous, completely foundational algorithmic and hardware transformations took what was a basic communication standard and morphed it into the pillar of modern ambient computing. I am super excited to guide you through this breakdown today, so let's get right to it. So think back to the early 2000s for a second. If you were around then, you definitely remember those awkward, constantly blinking blue earpieces. The ones that made everyone look like a slightly confused, low-budget cyborg. It was frustrating, it dropped connections all the time, and really, it was just a clunky wire replacement. But I want you to ask yourself, how exactly did that frustrating little piece of plastic evolve into the absolute spatial ninja that we use today? How did it become the invisible glue holding our smart homes, our high-fidelity audio, and our secure automotive keys together, all without us even noticing it's there? Let's kick things off with Section 1, the training montage. We are going from classic to low energy.
To really understand its current superpowers, we have to look back at its awkward adolescent phase. Classic Bluetooth had to operate in the globally unlicensed 2.4 GHz ISM band. It was a chaotic, crowded neighborhood packed with microwaves, cordless phones, and eventually a ton of Wi-Fi. So how did it survive? Well, it relied on frequency hopping spread spectrum, or FHSS. Think of legacy Bluetooth like a highly caffeinated squirrel trying to dodge Wi-Fi interference. It chops data into packets and rapidly hops across different channels, making a staggering 1,600 hops every single second. It's this frantic, brilliant hopping that let it mitigate interference in some seriously dense radio environments.
But eventually, the protocol had to go on a diet. With version 4.0, we shifted from classic Bluetooth to Bluetooth Low Energy, or BLE. Classic Bluetooth partitioned the spectrum into 79 channels of 1 MHz bandwidth, kind of like a gas-guzzling muscle car. BLE completely reorganized the whole thing. It shifted to 40 channels with 2 MHz spacing, and strictly reserved 3 channels exclusively for primary advertising. Instead of continuous, heavy streaming, it optimized for periodic, burst-like data transfers. This massive reduction in energy expenditure meant we went from needing daily charges to running a device on a single coin cell battery for literally years. Let's rapidly trace how these generations actually stack up. Version 1.0? Yeah, it had significant interoperability and security struggles. But then 1.2 brought adaptive frequency hopping to dodge that pesky Wi-Fi. Version 2.0 used phase shift keying to give us a 3 megabit per second speed boost. Version 3.0 literally hijacked the 802.11 Wi-Fi radio for high-speed transport. Then 4.0 sparked the BLE IoT revolution, bringing vital security upgrades like elliptic curve Diffie-Hellman cryptography. Moving on, version 5.2 fundamentally overhauled how we hear the world with LE audio. And today, 6.0 brings us unprecedented spatial precision.
Which brings us to Section 2, the superpower era. Let's focus on audio and spatial precision.
This is where we ramp up the professional knowledge, because from 5.x to 6.0, Bluetooth stopped being just a data pipe and became a highly tuned sensory organ. Bluetooth 5.0 doubled the bandwidth with a 2 Mbps PHY, or physical layer, and quadrupled the range using forward error correction in a LE-coded PHY. Then 5.1 introduced direction finding, angle of arrival and angle of departure, giving us centimeter-level indoor positioning. But 5.2, that is the absolute crown jewel for audiophiles, LE audio. Driven by the new LC3 codec, it delivers way higher quality at much lower bit rates and introduces Auracast, letting a single source broadcast to unlimited synchronized receivers at the exact same time. It's a real game changer. But looking at the 2026 realities, Bluetooth 6.0 completely elevates the protocol to an ambient awareness standard. The hallmark feature here is channel sounding. Historically, devices guessed distance by looking at signal strength, the RSSI, which is super susceptible to absorption and multipath fading. Honestly, it's like trying to guess how far away a concert is just by how loud the bass sounds through a brick wall. Channel sounding changes all of that. It bypasses environmental interference completely, kind of like a VIP skipping a massive club line. So what's the actual engineering behind that VIP access? Channel sounding utilizes phase-based ranging, or PBR, alongside round-trip time. Devices exchange continuous tones across sequential frequency channels.
By measuring the exact phase shift between transmitted and received signals at those different frequencies, the distance can be calculated with cryptographic decimeter-level accuracy. This dual-method approach completely eliminates relay attacks. It officially cements Bluetooth 6.0 as the definitive security standard for digital car keys and secure enterprise access control. No spoofing allowed. Moving right along to Section 3, the World Tour. Let's explore global philosophies. It's genuinely fascinating to see how different global markets take this identical core protocol and mold it to fit entirely different engineering philosophies. In the Americas, tech giants like Apple and Google use Bluetooth as the invisible glue for their walled gardens. Apple's custom silicon uses out-of-band BLE advertising packets tied to iCloud to prioritize a zero-friction, magical user experience over strict interoperability. Meanwhile, European philosophies pivot toward foundational standardizations. Companies like Ericsson and NXP are pushing LE-coded PHY for Industry 4.0 manufacturing and integrating Auracast into public transit for universal hearing aid compatibility. Then you have Asia, where manufacturers like Sony and Huawei are pushing aggressive hardware-software co-designs. Things like Sony's LDAC and Huawei's Nearlink blend protocols to hit microsecond latency and multi-megabit throughput, absolutely dominating high-end audio and gaming. Okay, hardware engineers, this one is for you. Section 4, the Oracle's Prophecy. Let's talk 2026 hardware strategies. What does the ultimate future-proofing playbook look like? You really have to triangulate power budget, required throughput, and spatial awareness. Looking at this definitive selection matrix, the choices are pretty clear. Building high-fidelity true wireless stereo earbuds, you have to use 5.2 or 5.3 to leverage LE audio and isochronous channels for multi-stream sync. Building a secure digital key for a car, you cannot compromise. You need 6.0 plus channel sounding to ensure cryptographic immunity against those relay attacks. And for massive retail deployments like electronic shelf labels, Bluetooth 5.4 is absolutely mandatory, using PAWR, periodic advertising with responses, to bidirectionally communicate with thousands of ultra-low power tags all at once. Mastering these PHYs is now a total prerequisite. And I want to be crystal clear about the architectural realities here. To survive, OEMs must adopt flexible baseband controllers capable of over-the-air updates. The transition to pure LE audio is accelerating wildly. Hardware that lacks dedicated accelerators for the LC3 codec is going to suffer catastrophic power efficiency penalties. Plus, because of channel sounding, antenna design must now account for multiple phase measurements. This means implementing complex multi-antenna arrays, even in the tiniest form factors, is literally no longer optional. You have to design for it from day one. Which leaves us with this final, slightly profound thought. By ruthlessly segmenting its architecture, maintaining legacy compatibility while birthing the BLE stack, and now layering channel sounding over it, the protocol has essentially secured its own immortality. As we step deeper into this era of ambient computing, Bluetooth is no longer acting as a simple data pipe. It's a highly precise spatial sensor and an incredibly inclusive broadcasting medium. So, is it just a connection anymore, or has it become our digital sixth sense? I hope this deep dive has given you a whole new appreciation for that little blue icon on your phone. Thank you so much for joining me on this explainer, and definitely keep your curiosity tuned to the frequencies around you.